internet that listed web URLs that you could go to in order to find things on the internet. That's kind of how there was no search engines back then. So the internet was kind of cool. People were playing with it. People were putting content out there. People were consuming content, but it didn't really, it wasn't scaling because there was no way to fund the infrastructure underneath the internet. All of that started to change in the late 1990s with three major platforms emerging. Social media came a little bit later. We had social networking a little bit earlier on. Social networking evolved into social media over time. But early in the late 1990s, we had Google figuring out how to actually do search. So you had a search engine that could find things on the internet. And you had Amazon figuring out how to do e-commerce. Before that, e-commerce was pretty sketchy. Like you find random websites. No one ever would want to type a credit card number in because it would immediately get stolen. So companies like Amazon and Google really were the first to figure out how to do something bigger with the internet. And the business model behind both ultimately was advertising data. I mean, Amazon was selling products and making revenue off the products, but there really wasn't much of a profit margin on the products that Amazon was selling. All the profit margin came from the ads that they would embed in the search process. And then social media came along and really took the business model of selling ads to a whole new level. This meant that the internet it grew by about 100x over the span of about, I think, 6 or 7 years. Massive, massive growth. And so now you have a whole bunch more people on the internet. You need computing, you need data centers, you need massive fiber optic circuits in order to really provide the infrastructure necessary for a much bigger, faster, now commerce-driven internet. And so we had to invent this whole new layer, what I'm calling the web layer, which included content delivery networks. Basically, the data you consume doesn't ever actually come from the website you go to. It comes from caches that live all over the internet that pre-position data so that it can deliver it to your device much faster, so you don't have the delay of waiting for an image to download from the other side of the world. The image you want is sitting on a data cache nearby, so everything loads quickly. And then cloud computing, this whole idea of basically building massive data centers right into the fiber optic infrastructure of the network, that was necessary in order to deliver all the data and services. The bottom layers look kind of the same. You still have TCP/IP gluing everything together. We had Wi-Fi come on the scene around this time. We had 3G and 4G cellular. Cable became a way to get internet from your home. We started to see metro fiber take off to provide connectivity in cities as really the way that you glue the lowest layers of the network together. This internet is principally the internet we have today. And this internet looks dramatically different than the old internet. This internet is basically controlled by 4 companies, right? You have Amazon, Google, Microsoft, Facebook. Those 4 companies control the vast majority of the bits that arrive on your cell phone or your computer every day. They control the majority of the data centers in the United States and also in Europe. They control and own the majority of the long-haul fiber optic cable that glues all these networks together. Google owns more undersea cable than most tier 1 telecommunications companies. And they have basically used ad money to build out this massive infrastructure of computing, communications, and storage that now is this big fabric that is the internet of today. And there's some concerns about that. What are they doing with all that data? And they're just the sort of Western half of this. You also have clones in China that are doing all of this as well. You have Alibaba, Tencent, and WeChat, which are basically one-to-one knockoffs of the US companies. And they are doing exactly the same business model in China, selling to countries through the Belt and Road Initiative, which is China's effort to really kind of push its technology out to the developing world, South America, Africa, and East Asia. So you basically have 8 major companies who control all the data in the world in this model. And again, like I said, there's concerns about how that data is being used. Here in the US, there's lots of concern about social media's algorithms that are sort of reprogramming our brains and making us consume media in different ways. We have concerns of technology being used to change outcomes of elections. Here, and then of course, sort of in the Chinese sphere of influence, you also have really the role of autocratic governments using it really to try and control and manage their populations, with China now sort of exporting their version of this internet to lots of countries through the Belt and Road Initiative to sort of would-be dictators in Africa and South America. So you get a lot of scale here. The problem is 8 companies own everything. They own all your data, and they own all the infrastructure. So there's been sort of this backlash to the vertical integration of Web 2.0, which is finely tuned for the business model that it operates under, to a decentralized approach. It says, well, it used to be everything was decentralized. We didn't only, back in Web 1.0, we didn't have 8 companies that ran everything. We had a big set of peer-to-peer networks that all glued together to make the internet. Anybody really was hosting web services locally. Can we get back to a more decentralized instead of a centralized approach? And that's what Web 3 is trying to do. And the way it does that is with a blockchain layer. We're adding yet another layer in the stack. And the idea here is that all data can be essentially public data and owned by the creator of that data. So no longer am I the one, like if I am, I don't know, posting something on Facebook, today Facebook owns that post. But in a Web3 world, I post something on a Web3 version of Facebook, it gets posted into the blockchain, and it's an NFT. It's that I own. Like I own my post, and I can sell it if I want to. And then anybody can access it, right, based on being able to interact with the blockchain. The blockchain becomes essentially this big, it's the database of the internet, of all of public knowledge, basically becomes indexed on the blockchain. And the content creators can own it rather than the tech companies. And then you can build out all of the services that sit on top of it. Different companies can build ways to interact with the data. And the business model is no longer advertising. The business model is cryptocurrency. So for me to post something on Facebook is going to, or the Web3 version of Facebook is going to involve a very small microtransaction of cryptocurrency. And the transaction fees associated with that would go to pay for the computers that are maintaining the blockchain infrastructure as part of the big network. So it's kind of interesting. It fundamentally changes the business model of the internet away from ads, which I think could have some benefits to society if advertisers weren't deciding everything we see on the internet. But, of course, cryptocurrency, I think, as I said earlier today, has been a dumpster fire for the last year. And so we are also, are we just trading one evil for another if suddenly Bitcoin is the underlying business model of the internet? So let me give you kind of a quick background on blockchain. I don't have time to go into too much of the details here. I'm sure many of you have probably seen versions of this before, but blockchain is basically just a data structure. You have blocks of data that are all chained together, hence blockchain. And each block has a cryptographic hash, or a checksum, basically, of the prior block. So it actually links them all together. And so if I want to change the data that's in block 3, I have to update the hash that's attached to block 4, which means block 4 has changed, which means I have to update block 5, which means I have to update block 6, and so forth. So it prevents an adversary from being able to change old data in the database. Once something happens, it's sort of immutably part of this sequence of events, and hackers are unable to retroactively go back and change transactions. The sorts of things that are in each of these are, the sorts of transactions that might be here would be like currency transfers. So Alice gives Bob, I don't know, 1 Bitcoin or something, right, is an example of a transaction that could be recorded in one of these blocks. All of this is distributed on a peer-to-peer network. So nodes all store copies of the blockchain, and they have a whole distributed algorithm for updates to it. So if someone comes along with a new transaction that they want to get added to the blockchain, it will get submitted to an initial pool of candidate transactions. Nodes will then mine new blocks. They have to basically solve a hard math problem to be allowed to create the next block in the blockchain. When they do solve that hard math, they all kind of race to do it. The first one that finds a solution to the hard math problem is then able to create the next node and takes a chunk of transactions and adds them to the blockchain. And then they can prove to the rest of the network that they solved that hard problem by showing the result of the math. And then that basically proves that they are committed to the network. It's called proof of work. And then the rest of the nodes will synchronize and will accept that new transaction that's part of, or a block of transactions into the network. And every time you want to do a transaction, there's transaction fees associated with that. And the winning block, the node that actually solves the math problem the first, gets to keep all the transaction fees, which is how they make money to pay for the underlying infrastructure. So again, kind of a cool new model. There's been all kinds of, we've learned a lot over the last 15 years of Bitcoin, well, 13 years of Bitcoin, and have learned a lot about how to make all this work efficiently. There's still all kinds of challenges with actual deployments of it, which I can get into. Cool thing I think about all this is this whole concept of smart contracts. So smart contracts say, well, how about instead of just the nodes having blockchains saved on them, what if we actually put little virtual machines on each one of these nodes as well? We can each one can have its own little programming language, and you can check algorithms into the blockchain as well. Not just transactional records, but you could actually store a small computer program in the blockchain. And so that's this idea of smart contracts. Smart contracts are basically things that run inside these lightweight virtual machines that run on the blockchain nodes. They are a Turing-complete programming language. They run as a stack machine. This is for Ethereum. Bitcoin has a sort of a version of this, but it's not Turing-complete, so it can't do very much. But Ethereum is the one that's got the full Turing-complete stack machine, so in theory you can do any algorithm you want on here. And it basically means that you can have a state machine that lives inside the blockchain. And these smart contracts are able to read and write the state, or read state from the blockchain. They're able to expose public functions that can be called. They can call public functions of other smart contracts. And they can transact cryptocurrency with one another and with users as part of their operations. So this, I think, is a really, really cool feature of Web 3.0. Basically, you can take kind of critical algorithms that we use every day and are important to society. You can put them into this sort of public decentralized network, and they will execute. And no one owns, like, if you designed it, like, they're not owned by anyone. You can create any governance regime you want in terms of how they're managed. So lots of different examples of them. One could be, and I'll get into an example of one of the very first one of these in a minute when I start talking about some of the security vulnerabilities. But again, and within Ethereum you also have things called dApps, which are the front end of these. The idea being you put a lot of the user-facing part of the app is separate, and you segment an app, so part of it lives in the blockchain, and that's the thing that sort of everyone needs to access, and then you can have a part of it that lives on an edge device as well. But there's essentially ideas of how to take smart contracts and blockchain and cryptocurrency and fundamentally change all kinds of different industries. So for the last, 12, 13 years, we've seen the world of decentralized finance. So that's cryptocurrency, and anything you can imagine in the world of traditional finance is now possible and more with cryptocurrencies. Like I can go out, I can take a loan out in cryptocurrency. I can do leverage trades. I can short cryptocurrencies. I can do all kinds of things. There's crypto hedge funds. There's crypto venture funds. There's crypto banks. All of these things exist. Any kind of financial instrument that you can imagine exists. And then there's derivatives on top of derivatives that are all out there that give you guaranteed sort of return on your crypto assets, for example. This has been a big bubble that it started inflating itself at the beginning of COVID when everyone suddenly was sitting at home and decided to become a crypto day trader. The market really kind of took off during COVID. And then in May of this past year, it imploded when basically someone decided to cash out $2 billion worth of Terra stablecoin. And the $2 billion transaction inadvertently created a ripple in the liquidity of a stablecoin that depegged it from the US dollar, and this death spiral began. That currency crashed. It then had these secondary effects on all these other currencies, cryptocurrencies. It took down a crypto hedge fund in the process because they had too much asset exposure to that currency. And then crypto prices dropped dramatically. And then, I guess now, a month ago, we had FTX also collapse when people realized that there was really it was all kind of a Ponzi scheme as well, with no actual assets under the hood. All the customer funds that had been deposited into FTX had all been gambled away by Alameda Research, which was their sister company, and spent on, I don't know, mansions and condos for SBF and his entourage. So anyway, crypto's kind of in a sad spot right now. If you look though at the value, basically we're back at pre-pandemic levels. So it had this crazy rise during the pandemic, and it has now crashed, but it's now back to kind of normal territory, in my opinion. And I'm hoping that this is now going to give us a more reasonable sort of economics to move forward with Web3. I talked a little bit about social media. Again, the idea here is that every time you tweet, your tweet is an NFT that's minted on the blockchain. And if somebody wants to like your tweet, they have to buy a tiny bit of your cryptocurrency. If somebody wants to comment on your tweet, they have to own a certain amount of your cryptocurrency. And so if you're a content creator, you can like directly monetize your tweets, and your followers who engage with you are sort of directly funding you through these microtransactions, and then the transaction fees on those microtransactions are paying to help subsidize the blockchain infrastructure underneath. And the idea is if you buy in early to an influencer and their brand appreciates and their cryptocurrency becomes more valuable, then you actually own equity, you own a stake in that person by owning some of their cryptocurrency, that also increases in value. And so it's interesting. It tries to create an economy around social media that tries to drive positive engagement, because now being a troll costs money and actually creates value. So if you're a troll who's trying to troll someone else, in order to troll them, it actually you're giving them money. You're paying them to troll them, and so it creates sort of this an economic disincentive to really have bad behavior on social media. So that's interesting. We'll see where that goes. Governance, like these smart contracts, for example, allow you to vote on things. There aren't major elections that are using it right now, but you've got sort of smaller elections that are starting to use blockchain-based voting. You've got entities that live entirely in the blockchain that are governed by voting tokens. And so if a smart contract needs to make a decision about how to spend money, for example, like they can put out, it will go out and ask everybody who owns tokens, governance tokens, to vote on a particular action. And I'll get into an example of that going horribly wrong in a couple minutes here, but those are some examples of some of the things you can do with it, this whole governance layer. Gaming has gotten very interesting. If any of these video games you play, you put your time into the game. In exchange, you get a currency. You make money in the game, right? There's in-game currency. You have a character that you're leveling up. You get items, I don't know, weapons, whatever it is. You increase the skill level of your character as your character is participating in the game. And so essentially, gaming is taking your time and converting it into sort of attributes and in-game currency as a sort of overly simplistic way, I guess, to describe gaming. I guess you have fun in the process. But the idea is, well, what if you made all of that transactable? What if I could take the in-game currency and just float that on the open market and sell it? So you could sell your currency in a game for Bitcoin or for US dollars for that matter. All your characters and all the items you might have are all NFTs that you could sell to other people, right? Right now, this happens right now sort of in an underground market. I don't know, with World of Warcraft early on started doing that, where, I don't know, people would create accounts and then sell the account after leveling it up a bunch. But now the idea with this Web3 gaming is it's all kind of part of the economy. Gambling, you can imagine as well. I can create a roulette wheel that just lives as a smart contract on the blockchain, and people can all place their bets. The smart contract can pick a random number and decide if or who won. It can make payouts to the winners and keep its own the losses it can keep in its own wallet that all live in the blockchain. And then, of course, the metaverse is kind of a whole other big topic, but the idea is as we all kind of find ourselves living increasingly in the line between physical and digital blurring, asset ownership in the digital half of our lives becomes increasingly important. And again, all of these, if you want to have a decentralized metaverse and decentralized assets that are in a decentralized metaverse, all of this is kind of part of it. So let's talk about some of the security challenges. The DAO. The DAO was created in 2016, right after the Ethereum blockchain started allowing smart contracts. It was the first big test of smart contracts to see if you could do something really new and different with cryptocurrency. And basically what it was a venture fund and a foundation that lived entirely decentralized in the blockchain. It didn't have a board of directors, it didn't have a management team, it didn't have an investor team. It just lived as an algorithm in the ether, and people invested in it. People put $150 million US worth of cryptocurrency into its treasury from 11,000 different investors. At the time, 14% of all Ethereum was invested in the DAO. And when you invest in it, you would get voting tokens back. And these voting tokens would allow you to vote on proposals. So someone might approach the DAO and say, I want $5 million to fund a food bank in Austin, Texas. And that request would go out to all the members of the DAO. The DAO could then vote yes or no with their voting tokens and decide whether or not this person would get $5 million. If they voted yes, then the treasury of the DAO would dispense $5 million to the wallet address specified by the person who made the proposal. You could also use it for investing in startup companies as well. You could do it for loans. There's all kinds of different models of the sorts of requests that could come in. And you could have democracy in action here, deciding what things to invest in and what things not to invest in. These voting tokens then themselves become valuable because you can start trading those on a secondary market as well. They basically become their own currency. However, someone discovered a vulnerability in the logic behind the smart contract. This started getting discussed on the Discord channel for the DAO in May, June timeframe of 2016, within a month of it launching. They said, oh crap, we've got to fix this, because basically it would allow someone to steal money straight out of the treasury without actually putting forward a proposal. And so they put together a fix, and they had planned to roll the fix out. However, the day before the fix was rolled out, someone actually exploited the vulnerability and stole $50 million from the treasury using this hack. It was the very first big hack against a Web3 infrastructure. Now, $50 million would not even make the news, because the hacks that are happening in cryptocurrency are so massive right now. But at the time, this was like the first big test of the cryptocurrency community. And it was so disruptive that the cryptocurrency community didn't know what to do. They didn't know, they say, well, we could change the blockchain, but we'd have to have everyone in the network agree that we're going to just go void that transaction in the blockchain, and we're going to take the money back. That, of course, fundamentally undermines the whole idea of a blockchain, right? The blockchain is the permanent record, and if you have a majority of the people running the blockchain deciding to just change the permanent record, then that fundamentally undermines the whole point of the blockchain. And so the community was split. We can't let people just go around doing fraud. The other side's, well, but just because it was unethical doesn't mean it didn't happen, doesn't mean we shouldn't allow that permanent record to continue. And so the Ethereum community at the time split. They forked into two. Half the community updated their blockchain nodes and said, we will, and removed the fraudulent transaction, and that is the Ethereum we know today. The other half refused to update the software, and that is now Ethereum Classic, which is a separate cryptocurrency that trades at a lower value, and that is the world where the fraud still happened. But the Ethereum we have today, the fraud was removed. And that's the last time anyone has ever proposed going in and actually trying to void a fraudulent transaction, because it was so existential to the community at the time. But what is a reentrancy attack, you might say? Well, here is an example of a smart contract. This is the kind of code that might be checked in to into one of these blockchain nodes. You've got a function, transfer, basically the transfer, who you want to transfer money to, the amount you want to transfer. It's very simple here. If your balance is greater than the amount, then add that amount to the recipient's wallet and subtract that amount from the sender's wallet. It's a pretty simple, 4 lines of code. However, you got to realize that this function call lives in a big distributed network. And so what happens is if 100 computers all simultaneously call this same function, and it kind of hits the blockchain all at once, then you've got 100 copies of this function that are all running simultaneously. They all do the first line and say, is the balance greater than the amount? Yes. Okay, then add the balance to the amount, to the destination, and then subtract. So, but the problem is you end up with 100 times, you end up essentially transferring this 100 times because all 100 of them pass the if statement, and they pass the second statement, and then it's not till the third statement where all the accounts are starting to go negative. But because they're all running in parallel, you end up with this problem where you can run 100 copies of this algorithm all at once, and you can basically, they all can all withdraw money from the account simultaneously. This is an example of a reentrancy attack. The way you fix this is you put a mutex around it, a mutual exclusion, which means that only one copy of this code can be running at any given time. You can't have 100 copies of it running all at once, and you got to wait for the first copy to finish before the second copy can run. And if you do that, then when the second copy runs, it would recognize that there wasn't enough money in the account to actually make the transfer. But this attack shows up everywhere. Almost all the attacks against smart contracts are because the developers haven't had a distributed systems class and don't understand the basics of multi-threading and coordination among a multi-threaded process and the need to have consistency and concurrency and what race conditions are in software. And so please pay attention in your operating systems class and in your, because this is a fundamental thing that is the vulnerability in almost all of the major crypto attacks right now is you just call this function a whole bunch of times all at once, and you're able to just withdraw a whole bunch of money. Here are just a handful of examples of where it's been used. There's been a zillion more. Some of these things are now $100, $200, $500 million attacks. The Dow at 50 million was tiny in comparison. Up next, we got the 51% attack. 51% attack is not ever really been used in real life, but it's something that everyone's kind of worried about. I spent a lot of time talking to congressional staffers who were trying to regulate cryptocurrency, and all of them are kind of worried about this hypothetical attack, but no one has ever actually kind of done this. And the idea here is that blockchain is resilient to what's called Byzantine faults. And what that means is that you can have bad data in up to half the network and still get the right answer. And the network will fix itself, and that bad data will get corrected because of the distributed nature of it. It's specifically designed such that as long as at least half of the network has the correct data, then adversaries can't do anything too shady with it, and eventually all of and if they are able to do anything shady, it will end up getting corrected as the blockchain consensus algorithm runs. But what happens if 51% of the nodes are attacked and are under the control of someone else? Then that is bad. In theory, it would allow those attackers to build consensus around an alternative set of data. How do you do this? Well, one way is to add new nodes to the network. That's really hard for like the Bitcoin network that has tens of thousands of nodes in it. You'd have to add tens of thousands of new nodes in it. And those tens of thousands of new nodes would have to use more energy consumption than the entire network today, which would cost a ton of money, especially given like Bitcoin currently is like the energy consumption, I think, of Switzerland or something. So you'd have to basically have an economy the size of Switzerland to afford to execute a 51% attack against Bitcoin today, just because of the cost associated with it. Another approach is not to add new nodes to the network, but actually to reduce the current number of valid networks. So if you can do a big denial of service attack against the Bitcoin network, and you can take enough of its nodes offline, then it actually reduces the number of nodes that you need to compromise in order to exploit the network. A recent study showed that about 40% of the Bitcoin network nodes are running outdated versions of the Bitcoin software. So if there's a security vulnerability or an exploit that's possible in an unpatched version of an old node code base, then maybe you could exploit the infrastructure. Or some sort of insider attack. So many of these nodes are not just sort of being run by random people. They're being run by large mining pools, and those mining pools have influence over large chunks of the network. From as many as 25% of the Bitcoin nodes in particular are controlled by these large mining pools. So an insider in one of those could also be a potential source of attack. Let's talk about some other attacks. Governance attacks. I talked about those voting tokens. Well, so a smart contract Once you check it into the blockchain, that code is there permanently. How do you ever make an update to it? What if you want to change the rules of your smart contract? You want to change something about your smart contract? Well, the only way to do that is to have an update process where the smart contract will allow, with like a supermajority vote of the token holders, the ability to change the smart contract. So you can put forward a proposal to the smart contract that says, I want you to replace your logic with this new logic. The old logic would then put out for vote among all the shareholders whether or not it wants this change, which basically would be like rewriting the rules of a contract or amending a contract. If the shareholders all vote yes, then the code would actually replace itself, essentially doing a software update on the smart contract itself. But everyone has to vote yes, they want this to happen in order to make it happen. And that prevents arbitrary people from just rewriting these tokens. But what happens is sometimes these governance tokens are worth money on a secondary market. And so people start trading them on these secondary markets and build derivatives out of them. So the Beanstalk attack earlier this year, what somebody did was they used a cryptocurrency lending service. They got a flash loan for a whole bunch of cryptocurrency. They put up 10%. They got, I don't know, I think the attack maybe cost about $1 million to execute. I think it was like I have no idea actually how much it cost to execute. It was probably tens of millions of dollars to execute. They got a loan for tens of millions of dollars. They went out and bought on the secondary market up a whole bunch of voting tokens. They then proposed to the smart contract new logic that was just pay me all of the money that's sitting in your treasury. It then went out to the stakeholders for a vote. They had bought 51% of the voting tokens. And so they approved the measure to give them all of the contents of the treasury. They then got the contents of the treasury. And before the value of the smart contract and the currency underneath it collapsed, they then paid back their flash loan. I'm sorry, they sold all the cryptocurrency, the voting tokens that they bought, back to the people that had them before, and then they paid back their flash loan. And then they got their deposit back. And so this is an example of using essentially this leveraged buyout of a currency to do a brain transplant, replace it with logic to just give you all the money. There are solutions to this. I'll talk about a little bit later. Quadratic voting is one way to do this, where it's not how many voting tokens you have, but you need to, each voting token, each wallet can vote as only the square root of the number of voting tokens it has, and it makes it much harder to do these kinds of attacks. Another example is credential theft. So this is what North Korea has been doing for the last 2 years. You have what are known as multi-signature wallets. So this is a Bitcoin wallet that requires multiple keys. In this case, you might need 2 out of the 3 keys to be used to unlock the wallet and be able to transact using this particular wallet's resources. And the idea here is that you can distribute trust among multiple people. And so there's been a whole bunch of attacks against bridges in particular. A bridge is where you have 2 different blockchains, each with their own cryptocurrency running on them. And a bridge is a smart contract that sort of connects the 2 of them together. There's a smart contract on one blockchain and a smart contract on the other blockchain, and then they each have their own little treasury, their own little reserve. And if somebody wants to trade currency 1 for currency 2, they'll go to the bridge, and the bridge will deposit their money on one side of the bridge, and then they will cash them out on the other side of the bridge with the other kind of currency. It's basically just a way to do trades across multiple blockchains. It's through these bridges. And the wallets themselves, though, you've got these wallets that are basically holding escrowed cash that is being traded back and forth between the 2. And those wallets have these multi-signatures, so not just one person can go in and empty out the wallet. But there were 2 examples, the Ronin Bridge and the Harmony Bridge, where basically North Korea just fished their way into enough of the developers' computers to just steal the keys. One of these required, I think, 3 keys to be stolen. One of them required like 8 keys to be stolen. But they were able to just fish their way in, get the private key, the pieces of the private key, to assemble enough pieces in order to unlock the wallet. And once they've done that, they can just issue a transaction on the blockchain to give themselves all the money. But again, yeah, still socially engineering, still phishing. And these 2 added together were $1 billion. And this was just 2 of the attacks. In the last year and a half, North Korea has done this to steal $2 billion worth of cryptocurrency. And that's how they're currently paying for their nuclear weapons program, is by stealing cryptocurrency. So this is a fascinating example of the future of cyber warfare, is basically rogue nations acting like criminal enterprises and stealing cryptocurrency that they can use to finance kind of broken parts of their economy. Rug pulls, this is another major part of fraud that's happening in the world of cryptocurrency right now. Basically, everybody's trying to make money, and so everyone's dumping money everywhere, and lots of greedy people will just do outright fraud or insider attacks where they'll build backdoors into their smart contracts that either prevent their investors from cashing out or allow the creators to just steal all the money directly and then run away. A lot of this is because investors are not doing any due diligence. They're never looking at the smart contract. They're never saying, let me see your smart contract. And if you look at the smart contract, you can say, oh, look here on line 17, there's a function call that says defraud all my investors, right? And you're just going to call that. So maybe I shouldn't invest with you. But because that due diligence isn't happening, because everyone's been so crazy about trying to make a buck wherever they can, it allows people to just do outright fraud. Back to our phishing attacks and scams. This one here in the middle is one of my favorite. This is from 2 years ago when Twitter got hacked. And the biggest thing that they could think of to do at the time, because it was a bunch of kids in Florida, as I recall, they used their stolen access to a bunch of celebrity Twitter accounts to send out Bitcoin scams. And you can kind of joke, like, all Bitcoin sent to my address below will be sent back and doubled. You send me 1,000, I'll send you 2,000, right? It seems like so obviously a scam, but they still banked $150,000 doing this, of people sending Bitcoin because of this. So there's all kinds of examples. This is Discord. So there was a big issue with Discord where people were basically phishing the credentials for the major creators behind NFT projects, and then logging into the Discord servers as the people behind the NFT projects, and then using the inferred credibility to advertise, I don't know, dropping new NFTs and then running scams and defrauding everybody. We also have outright terrorists and money launderers taking advantage of this. This is part of the reason why cryptocurrency's gotten kind of a bad reputation, is because one of the major users of it is terrorist groups and organized crime. So ransomware has become was really one of the early drivers behind a lot of this. Lots of things, a longer conversation about sort of ransomware and how we got to where we got to. Monero is a privacy-preserving cryptocurrency. It's really hard to track adversaries who use Monero because you can't, the source destination information is encrypted in the blockchain. You can't just see it unless you are a party to the transaction. So it prevents law enforcement from just sort of sniffing the blockchain data to figure out who sent what to whom. And so Monero is often used by ransomware groups. Tornado Cash is another. This is a money laundering operation where basically everybody can dump their money into Tornado Cash. It all gets mixed together with everybody else's money, and then it gets spit back out again to other wallets, and you can't trace the input to the output because it's just a big mixing service. And it makes it a lot harder for law enforcement to track individual transactions. Tornado Cash has recently been sanctioned by the Department of Commerce and a whole bunch of addresses associated with it, because in North Korea in particular, because they were using it to launder all of the money they stole from those bridge attacks. And that gets us to the big examples recently. Terra Luna was the one that really completely undermined the back in May, and then FTX most recently. This was essentially, this isn't cyber attacks. This is really just, cryptocurrency is a financial ecosystem that we don't really understand the kinematics of it, right? We don't understand how a change over here affects things over here. We don't understand how a big disruption here affects this thing over here because it's also new. We don't have good models for the financial, for the markets that underpin it. We also don't have good regulation that's helping to damp the oscillations that cause everything to explode. So the lack of regulation that try to keep everything calm, combined with not really understanding all the connectivity between it, results in these two major cases essentially unraveling much of the value in cryptocurrency today. So at MITRE we have this thing called MITRE attack. MITRE attack is really trying to understand what your adversaries want to accomplish and then building your defenses to prioritize detecting and countering specific adversary tactic, techniques, and procedures. The idea is that attack isn't just an adversary coming to your network to do one thing and then leaving. There's a whole pattern of life associated with an attacker coming after your system. They have to do the reconnaissance up front to figure out what they want to attack. They have to find an initial entry point. They have to do some initial exploit to get on your network. Then they have to move laterally through your network to find the place they want to get to. They have to set up some sort of beachhead there and remote access. And then they have to snoop around on your network to find the data that they want and get it out of your network. So all these steps all have to be kind of glued together. We call this sort of the cyber kill chain. Each of these are represented by a column here on the MITRE attack framework. And the idea is that every adversary group has a different signature. They do different things in this step. And so you can start to recognize Russia versus China. You can start recognizing Russian military versus Russian intelligence. You can start recognizing organized crime. All of these different threat actor groups have their own style in how they work through this matrix. And if you understand that, you can much better design your defenses to protect yourself against them. And so MITRE attack has been a big part of what my company has been developing and really trying to bring to the cybersecurity community. And I guess I'll highlight, I am wearing my MITRE attack socks, which Sid noticed earlier. Anyway, so one of the things that we're doing as a company right now is trying to build attack for Web3, where I take all of those TTPs I just described, different threats to the network, and figure out how to implement them for Web3. Another big thing we're trying to do is cybersecurity standards. So like, in particular, we're trying to get NIST to do this, National Institute for Standards and Technology. Can they develop standards for cryptocurrency and smart contract security? Can we come up with who has to implement these security standards? And it should be things like, if you're going to publish, if you're going to put a smart contract on the blockchain, maybe you should publish the source code so people know what's in it. Maybe you should use actual formal methods. Like, there's a whole field of computer science. It's about formally proving that the logic in something is correct. Can we actually use that to verify these smart contracts and prove that they're correct before we put them out there such that an adversary could exploit them? Here's a simple example of using ChatGPT, which has sort of exploded on the internet over the last week and a half. Here in ChatGPT, this is an example of giving a snippet of smart contract code to ChatGPT, and ChatGPT immediately recognizing that there's a reentrancy vulnerability where you can do this withdrawal function multiple times, and that the solution to it is to put a mutex in there. So it's just kind of interesting to see. Even ChatGPT can recognize when someone's smart contract can be exploited at this point. So can we take some of this kind of technology and make sure that the smart contracts we're deploying out there actually are secure? These aren't very complex algorithms, and so they're perfect for trying to use formal proofs of correctness on. So this is something that I'm spending a lot of time working with congressional staffers on right now, because once the new Congress is seated, this whole giant mess of cryptocurrency legislation is expected, and we're trying to help the staffers on the Hill put together legislation that will not be, again, congressional staffers aren't very good at writing cybersecurity regulation, and that's kind of where we are. So we're trying to help make sure they do it correctly. There's also information sharing that's necessary. So in any cybersecurity discipline, basically the idea is you bring these groups of people together that have similar sorts of networks for them to share information with one another about the threats that they're facing. Information sharing and analysis centers, or ISACs, this ecosystem's been around for close to a decade, and it's really about sharing threat intelligence across different groups. We think there needs to be something like this in Web3, where the crypto exchanges and law enforcement and the people who run the blockchains can all get together and sort of share information with one another about bad actors that are using them. My company worked with the Department of Justice to launch something recently called the Illicit Virtual Asset Notification Platform, or IVAN. And this is basically a partnership between the crypto exchanges, the banks, and federal law enforcement to help alert each other when they see potentially illegal activity. So law enforcement can say, hey, this wallet address looks like it's up to no good, and the crypto exchanges can go take that into advisement and decide whether maybe they want to sanction it, maybe they want to block it, maybe they want to just put an alert on it. Meanwhile, the crypto exchanges can do the same thing. They'll say, well, we see this group of wallets over here doing this behavior that we don't think is legit. Let's inform the FBI. So, and then, like I said, there's this whole field of tokenomics, which is the economics of crypto tokens. And it's still very new. We don't have good models for how all these smart let's imagine you just take all these smart contracts and you give them all the ability to call each other and create dependencies between each other. And they all are in steady state, and they're all kind of working properly. This one's talking to this one, this one's talking to this one. Everybody's trading money around the way you would expect them all to. But then somebody comes along with $2 billion and just clobbers one of them with a $2 billion withdrawal. It's then going to, there's a ripple that then kind of flows through the whole system. And because they're all connected to one another, we really don't understand how that ripple is going to propagate through. And I guess what we've seen is that recently ripples that should have been small ended up getting amplified and taking down entire big chunks of the crypto community. And that's not good. We need regulation to help essentially flatten out the volatility. So there's this whole thing about can we do better modeling and come up with digital twins for these things to model the systemic risk that you have in some of these systems. And then you can also use them proactively to say, well, if we want to reduce the volatility over here, what new policy do we need? And you could actually digitally test new crypto regulation and understand how it would affect the market, all digitally. And then you could, if it works, it does as intended, then you could enact it. So, and the idea is if we can start to solve these issues, then we can kind of clear this big morass of cyber insecurity off of blockchain, and then we can start building some of these cool new Web3 things on top. Now that we've had the cleansing forest fire of crypto crashing, maybe we'll have an opportunity to kind of start anew and really build some of this cool stuff on top of blockchain that's not so hyper-financialized, but really focused on solving real problems for real people. And with that, I'm done.
Thank you. If you've got a question for Dr. Clancy, let me know. I want to bring you the microphone because we're streaming and recording.
Hi, my name's Sebastian Humer.
Hello.
Okay, and thinking about your question, I have a few questions. First of all, you are aware of something like proof of stake and stuff. Mm-hmm. First of all, can I ask your opinion about that?
Yeah, so proof of stake is a different approach to consensus. What I described here was proof of work, which is essentially where you have to solve a hard math problem to be allowed to create the next block. Proof of stake basically says you get to create new blocks based on the having a large ownership stake in the underlying infrastructure and locking that ownership stake up for a period of time in the underlying asset. So you've bought in. It's a different way of buying into being allowed to make the decisions. Proof of stake dramatically reduces the energy footprint, so I think it's an important piece of this. Without it, we've got major sustainability issues in terms of energy consumption. There are some who say that proof of stake makes it easier to execute certain attacks against the network. It makes it easier, basically, to just buy your way in to exploiting something. But I would guess if you're going to spend a whole bunch of money to buy your way in to break something, I'd argue if you now own more than half of it, it's sort of a you broke it, you bought it kind of situation. So I'm not entirely convinced that there's an incentive to buy 51% of some asset class only to then tank it and undermine the value that you just bought. So I don't know, but maybe there are actors out there who are just looking to disrupt things and not trying to do it purely for financial metrics.
And second question, also because I am on the same page in which I feel like there is, for cryptocurrency to thrive in the future, there is going to need to be some regulation and stuff around it. But on the internet and stuff, I hear about some people who claim that basically the best way I can describe it is if any regulation goes around cryptocurrency and stuff without they pretty much are heavily so against regulation and stuff, and they pretty much see this whole idea of regulation on cryptocurrency to be something, let's say something that fundamentally goes against the spirit of cryptocurrency and will pretty much destroy the purpose of what cryptocurrency
Right.
will do, and we basically got like the dollar bill and credit cards again, where the government, the best way I can describe it is government tracks you, FBI kicks down your house and stuff.
Right.
Basically, they can track you forever, much like Amazon and stuff, and we basically are like on the Huawei, like spy state,
Right.
but USA edition.
So there's,
Can I ask your opinion about that?
yes, there's a whole bunch of different dimensions there. So first, no one wants to regulate all of it. The idea is we always need permissionless finance, which is kind of the name we give to the unregulated part of cryptocurrency. It's kind of like interacting with cash. You always want the ability to transact in cash. And so we want to make sure that there's always a segment of the crypto community that is transactable like cash. Second, I think if we over-regulate it, we stifle innovation. All these cool Web3 things I'm talking about won't go very far if it's over-regulated, and even to do a basic experiment with a new kind of token, you have to go to the SEC for approval, right? That would stifle innovation. So I think where we're looking at regulation initially, first is around custodial exchanges. So if I'm an exchange like FTX, and I'm taking real dollars from real people, and then I'm gambling those real dollars away, that's bad. That is not so much an issue with cryptocurrency as it is FTX is a company that is taking money from people and defrauding them. So we need to essentially regulate custodial exchanges similar to the way that we would an investment bank or a retail bank, because we need, and by doing so, we also need to give them protections. Like, if we're going to regulate you, we also need to give you FDIC protection, for example, so that if your assets go poof, there's a way to get your money back. Stablecoins are another big part where we need regulation. Stablecoins are meant to always exactly equal $1 in trading value, and they are a key way to manage risk in cryptocurrency. And so one of the big areas we're looking at right now is on regulating stablecoins so that they have basically the same sorts of safeguards that a fiat currency would. And the idea is that they would have access to the Federal Reserve for liquidity if there was some sort of major issue. They could get the same services that any kind of bank could get if they run into some sort of liquidity crisis. Those are only kind of two parts of a much bigger crypto ecosystem, though, and the idea is that you can still have the wild, wild west over here. Maybe some parts of it you want to govern like commodities and make people pay taxes on it, maybe not. But you're going to see a kind of everything from the very safe crypto assets, like regulated exchanges and stable coins, that arguably don't look any different than credit cards and US dollars, but they have a digital interface to them, so they allow a digital economy. But then you can seamlessly see all the way over here to the wild, wild west of things that are much more privacy-focused and anti-regulatory in their construction. And the world's big enough for all of them. We just want to make sure that the retail investors have the ability to invest in the safe stuff if they want to play in this domain, and that they're informed of what they're getting into so that they're not constantly being defrauded is the basic goal.
Thank you.
Any other questions? Yeah.
So most of your arguments and everything, it's all revolving around essentially given value to interactions and different smart contracts and everything like that. What happens then to the ideas that are like the open source ideas where you make it for free and you distribute it for free and it's supposed to be free for everything?
Yeah, so that's a great point. This whole movement towards decentralization doesn't necessarily require monetization. And so I think that's an excellent point. So open source software is a good example of something where you don't want to monetize every, git commit or pull, right? That's just sort of antithetical to the underlying goal of what you're trying to accomplish. And so we're starting to see decentralized, I would argue that GitHub and our open source community today already is a decentralized community that has got a very loose governance on top and allows communities to come together to do collective software development. Great. We've also seen social media like Mastodon show up in the wake of all this anxiety over Twitter. And Mastodon, again, is not blockchainified. It is this federated network of servers that people will run and communicate on and collaborate on. The problem with Mastodon, though, is when you open up your Mastodon app, the very top banner is, click here to donate $25 to your local server admin who's running this for you. So there's no business model that allows decentralization to scale in certain cases. So for communities where the goal is not to make money, I think like a Mastodon or a GitHub open source environment, and everyone is willing to contribute with and share the costs, great. Where you actually need scale, like as I said, the transition from Web 1 to Web 2 was figuring out the business model that allowed the internet to take off. And for decentralized applications that today only flourish with one of 8 companies behind the curtain pulling the strings, this is a way to basically generate enough economic value to replace them if you want to, and still be able to pay for the massive infrastructure that's necessary to run the plumbing under the hood. That's not to say you can't do it without that. It's not going to scale because you're going to the finance. Even Mastodon is an example where you're relying on individual donors to pay to run the infrastructure. I think is interesting. We'll see how large Mastodon can scale with that as an underlying requirement to basically fund the economics of it. Whereas cryptocurrency gives you a very efficient, economically efficient way to cover those costs. So I think we're going to see a mix. And I don't know how fast we're going to see which one grow in which dimension, but I think it's going to be fascinating to watch.
So you'd mentioned the quadratic voting for the smart contracts in the past. What would prevent that from also being similarly exploited by an attacker?
You could, it just would be harder. So the idea is, in this case, I can go off and buy 51% of the voting tokens and put them all in a single wallet, and then I vote with that one wallet, and I get 51% of the vote. If I do quadratic voting, and I vote, I've got 50, let's say, whatever the square root of 50 is, something like 7 or 8. 8, yes, a little over 7. If I'm doing quadratic voting, that wallet with 51% of the voting tokens only gets 7% of the vote. And so in order to win, I actually have to take those tokens and put them in a whole bunch of wallets and do like a Sybil attack and split my voting tokens up with like 1 token per wallet. And that's possible, but it's a pain. And it just creates a lot more complexity and cost for the adversary to be able to execute an attack.
Makes sense. Thank you.
Yeah, regarding the database for the threat intelligence that you talked about, the signature of unique cyber kill trains deployed by different adversaries, is that something we can also use? Is that in a form of data that we could also use to employ offensive operations to deceive and manipulate our adversaries in our own offensive operations?
Yeah, so MITRE ATT&CK can do all of those things. And MITRE ATT&CK is this big database with pretty much, so just to kind of give you a quick taxonomy of the MITRE ecosystem. MITRE ATT&CK is really the knowledge base of all of the adversary tactics, techniques, and procedures. Under the hood of each one of these squares is going to be a list of all the different CVEs, all the individual vulnerabilities that would allow you to execute these steps. So, I don't know, this network sniffing. Well, okay, what are all the tools that you can use to do network sniffing? I know, port knocking. What are the different tools you can use to do port knocking? So each one of these, underneath, there's lots of different CVEs that an adversary would use to actually execute them. And this is about how you knit them together. This is one database and one tool set, along with CVE, which is the actual individual vulnerabilities and the enumeration of all of them. We also have Caldera. Caldera is an open source tool for red team automation. Basically what it does is it has all of these attacks pre-programmed in them, and it also has the behavior patterns for certain nation-state actors already programmed in them. So what you can do is you can actually download Caldera And you can say, all right, if Russian SVR was going to try and hack into my system, what would they do? And you can load up the Russian SVR TTPs, and underneath it actually has the exploits, and it will run the exploits against whatever network you targeted at. And it will automate each of the steps as if it was a Russian SVR hacker. So that open source tool exists. It's called Caldera. You can download it. There's a whole bunch of modules available that do a bunch of this stuff that are all free and open source. Then we've got a whole bunch of ones that we've developed for the government that are more sensitive or classified because they're based on classified knowledge of certain adversary behaviors. And then the third component of this is what's called MITRE Engage, which is the deception part of this. If you know how an adversary plans to attack your network, then you can create traps for them, right? You can create honeypots that they will get tripped up in because you know what their patterns are. You know how to put something juicy out in front of them for them to hack into and get lost in sort of a mirror maze of a fake network that's particularly designed to keep them engaged because you know their pattern of engagement. And so that's called MITRE Engage. It's also, you can find it at engage.mitre.org. But it looks something like this, except it has each of the different steps that you would use in order to execute a deception operation. And we have a bunch of tools we've developed internally that actually help you create deception environments that look very convincing. We haven't released most of those to open source because we still use them heavily for actual operations with primarily the FBI and helping them basically trip up hackers coming after the US. But that's kind of that whole ecosystem. You can find it all on our website.
Thank you.
This is probably our last question, running out of time.
So you talked kind of at the beginning about how like there's 8 companies that kind of run the internet in Web 2. And now like with Web 3, you'll have like this kind of like token ownership. How is it different though from like just big money can take over these infrastructures? Can they not also just take over the ownership of these tokens with their money as well?
They can. I think there's a few things that are important. One, you want to make sure that the infrastructure is actually decentralized. For example, I can create a blockchain with a single node, and it does all the blockchain stuff, but it's not actually decentralized, right? Because still one person owns and controls the whole thing. So there's a lot of things that are Web3 in technology spirit, but not actually in the underlying ethos. So there's a lot of questions about making sure that the services you're using actually are decentralized and that their ownership interests are sufficiently diverse to meet the underlying objectives. No doubt you'll see major tech companies buying into this ecosystem, but the point is the barrier to entry is much lower. So in theory, anybody can buy in. Not just the people who own all the fiber optic infrastructure and all the data centers in the world. There's not that barrier to entry anymore, and so you'll have, no matter what, a more diverse set of stakeholders that are buying in. And also the other thing is the data that you create is owned by you and not by anybody else unless you decide to sell it to somebody. Like an interesting example would be health records, right? We could create a private blockchain that has all your health record data in it. And if you wanted to participate in a virtual clinical trial, you actually could rent your data to a pharmaceutical company for use in some sort of virtual clinical trial and actually make money off of it. So it puts you in control of the data and how your data can be used and allows you to make money off of it. Whether you're a creator on social media or you want to decide, sure, I'm willing for this website. I don't know, you check the box saying, yes, I accept all cookies, right? In theory, you should be able to make a little money off that if you're willing to accept all the cookies when you go to a website. That's the idea, is that by owning your data, you'll be able to make those decisions. The problem is right now that there is no user interface for all of this infrastructure is inaccessible to the average person unless you are using a handful of apps that sit at the top, because and that's a problem. So one example would be OpenSea, which is a website for trading NFTs. A bunch of NFTs were getting stolen and being trafficked, and OpenSea was marking them as stolen and trafficked and not allowing you to transact them. But that didn't prevent you from transacting them directly on the blockchain if you knew how. You just had a user interface that was preventing you from doing the transaction because the user interface thought it was stolen. That doesn't stop, but the point is, you can go download a different user interface and go to a different user interface that's accessing the same blockchain and use that instead. Same thing with social media. If you don't like the order the tweets are being shown to you because you have some concern about the algorithm censoring people, you can use a different social media interface that accesses the exact same blockchain. And so you now have diversity of choice in the tools that you use to interact with the data as well. So that the idea is to prevent the user interface from being the thing that is somehow misrepresenting the data or censoring the data. So, all right.
All right, well, join me in thanking Dr. Clancy. Institutional Advancement and Academic Affairs would like to present you with this little token of our appreciation for your
right.
time and knowledge. Oh yeah, very, very important. This concludes the cybersecurity seminar for today. Thanks for coming. Hope to see you next time.